The greatest revolutions aren't made with weapons, but with ideas. And today, those ideas are powered by technology. Good morning, everyone. I, Sahiti, welcome you to today's knowledge-rich session where we will dive into two of the most powerful forces shaping our industries: industrial IoT and AIoT, and digital quality in pharmaceuticals. As the world pivots towards smarter, leaner, and more connected operations, we are witnessing a remarkable shift in how products are made, systems are optimized, and quality is ensured. We are truly honored to have with us two seasoned technocrats from Infosys Limited who will walk us through these future-ready transformations. In a world of hyper-connectivity, industries are no longer just digitizing, they are becoming intelligent ecosystems. The Internet of Things, IoT, allows machines to communicate, collect, and transmit data, while artificial intelligence, AI, empowers the data to make smart, fast, and meaningful decisions. When combined, IoT and AI form AIOT, accelerating operational efficiency, automation, and predictive decision making. This is especially transforming sectors like pharmaceuticals, oil and gas, and manufacturing. Our first speaker today will walk us through this revolution. It is my pleasure to introduce Mr. Amit Kumar Rath, Industry Principal at Infosys Limited, Bhubaneswar. He holds a BE in Computer Science and brings over 21 years of rich experience. Mr. Rath is a distinguished technologist specializing in industrial IoT consulting, MES technology, and smart manufacturing. He has delivered transformative solutions across USA, Germany, Romania, Hungary, and more, focusing on IT-OT convergence, energy monitoring, MES modernization, and industrial digitization. He is also author of notable blogs like Cloudification of MES and MES in a Nutshell. Today, he will speak on IoT to AIoT, accelerating digital transformation. Please join me in warmly welcoming Mr. Amit Kumar Rath. Sir, the stage is yours.
Good morning, everyone. Rather, I would say good morning, my friends here. So, looking forward to have a very collaborative and interactive session with all of you. And thank you very much, Mr. Sangram sir, and other faculties here who had a great welcome for us, myself and Manoj, who are here for today. So, as we get started on this, right, as you know, the world has changed drastically over the last 5 years, right? We all saw the COVID wave, and then post-COVID, the geopolitical situation has changed, right? There are a lot of wars all around, and as you know, right, now no country is friend or an enemy, it's all frenemies, right? That has evolved over the period of time. And with that, now comes the technology, right? So technology has to play a very important role, right, in shaping of the world, in shaping of the future, not only for our country India, but for the entire world, right? And now from that perspective, today we are here to discuss a very relevant subject, artificial intelligence, right, which is now the heart of the technology, which is truly going to shape the world, right? And then combined with Internet of Things, which more brings in the industrial level, right, on how we can streamline the manufacturing, how we can primarily ensure that we bring in an operational efficiency, we bring out the best, right, out of every manufacturing sector that we have in this law. So So as I start with the subject, I'll walk through few of the quotes and quotes, right, from some of the industrial legends, some of the intellectuals on artificial intelligence. Right? To start with, quoting from Marvin Minsky, right, the founder, kind of founder of AI, who calls out it's more of a science of right, designing the machines who can work by themselves, machines who bring in brains, who bring in intelligence within, right, bringing in a human intelligence that is plugged into the machines, right. So another one, interesting one from Guinea, right? So the former CEO of IBM, right? He calls artificial intelligence is more about augmenting our intelligence. So the idea of right, Guinea is more to bring in human intelligence plus a computer or machine intelligence together to basically save up the world. These are some of the positive quotes, but nevertheless, right, I have few other quotes which basically calls out the other side of the artificial intelligence, and that is what the whole world is worrying about, right? So Elon Musk, one of the famous entrepreneurs, right, he calls out with artificial intelligence we are creating a kind of a responsible, right? We are trying to kill ourselves, right? That is the vision that he mentioned. Now, how much that would succeed, what would be the future, right? It's interesting to wait and watch for. Another interesting quote from Stephen Hawking, who compared artificial intelligence to drive over the human intelligence, who calls out that there would be a day when it would eventually, right, end the human race. Human intelligence, it will supersede human intelligence, and then, right, it goes over that. At this, I'll leave it to all you audience, right? We should stay optimistic. We should look forward to the technology. At the same time, these are some of the great leaders, right, who also see the other side of it as we move forward. Now, coming to the agenda, so we will start with some basics, right? We'll understand what is IoT, what is artificial intelligence, why there is a collaboration between IoT and artificial intelligence. We'll understand the industry of the hour, right? So what are the current manufacturing trends, how the industry is shaping up, right, with technology, and how technology is being used by the industries, right, to primarily bring in the best out of it. Then we'll discuss about a couple of good use cases that, because I heard from Dr. Sangram sir that right, there are a lot of people, a lot of audiences here who are from pharmaceuticals background. So I've got a couple of use cases, one obviously from life sciences, and there is another manufacturing use case that we'll discuss, right, how technology has helped to shape up some of these industries. Then nevertheless we'll speak about few of the challenges, right, that comes with all this technology and technical innovations. And finally we will pick into the future, right, understand where the future lies. Again, this is my own view, right, definitely there can be multiple views and there can be divergent views, but we will eventually discuss on, right, on where are we heading to. Moving on, what is IoT, right? So IoT is basically, it brings in life to a device, right? When there is a device, a physical device, and that physical device is embedded with sensors, is embedded with technology, with software, with information technology, it eventually brings a life to that device. The device starts interacting, starts talking to the environment, to the community, to the people, to the processes. So it becomes a part of the universe, it becomes a part of a process and environment around it, right? So that is all about IoT. Now, how artificial intelligence, what is artificial intelligence rather, right? So artificial intelligence is something which brings in, right, which leverages, which brings in a human intelligence into a device, right? Which brings a human intelligence into systems and machines around it. and it is able to recognize the natural language, it is able to recognize the patterns, it is able to recognize the images, it is able to recognize the features and attributes of the object, of the sensor, of the device, whatever it is, of a physical object, right? So that is where the way you can recognize, for example, you are looking at this video camera, you can recognize about the features, you can recognize about the lights, about its capabilities. The same way, the technology should be able to recognize dynamically on the fly anything that comes in front of it, right? So now we have to we'll discuss on, right, the evolution of a product. Some warning out there, sorry. Sure. Okay, now we'll discuss about the evolution of a product, right? So as I said, we have got a physical product, which is nothing but a product which is made of mechanical and electrical components, right? You can take anything as an example, right? For example, I'll get to a very simple example, a car, right? A car is built through multiple mechanical and electrical components, right, embedded within it. Now, if I have to say that it's a smart product, what does that mean? So smart product basically brings in, right, on device software. So you have software embedded into your car, you have got your audio visual systems embedded into the car, you have got, right, lot of other sensors. For example, it can measure your braking technologies, it can measure your tire pressures and so on. So that becomes a smart product, right? Then we come to smart connected product, right? Once you bring in smartness into a device, once you bring in technology to a device, once you are able to understand the data generated from that, right? And in this case, car, right? So now it comes to about a connectivity, whether the data can be connected to other systems over the cloud, over the internet, and it should be able to share informations, right, with the peripherals, with the environment. So that is your smart connected product, right? Now, most importantly, what is AI driven connected product? So now you have, as you can, I'll go back to the evolution. You have a product, then you have a smart product which has got technology fit into the product. Then you have got smart connected product which enables your product to be connected to the external systems and external world. And then you have got a AI driven connected product. AI driven connected products eventually leverage the learning experience the product that faces on a day-to-day basis, right? So when you drive a car, it collects all the informations, right, about your car. For example, it collects the speed, and at what speed, what is the vibration of the car, at the speed, what is the heat generated out of the engine. So it typically collects all the informations about your car, right? Use that as a learning, and then based on that, it helps to basically create a situational awareness, right? The situational awareness is something which will help the driver to understand when he is driving the car, right? It will give you a lot of instructions driven through the data created based on all the historical trend and analysis of the data, and that is where it will kind of guide a driver, right, through the intelligence of the system on how to navigate further, right? So now with that, how do I link IoT and artificial intelligence, right? While IoT or Internet of Things brings in, right, internet, brings the devices into the internet, brings in the data out of the devices, right, through the smart product ecosystem. Artificial intelligence is all about the analysis that we do over the data, right, creating a mechanism on the data analysis and then eventually amplifying the value out of the data. That is all about artificial intelligence. So together, AI and IoT will bring in will start from the data collections, analyze all the historical data and trends, and then eventually get into the results that can be used to improve your day-to-day efficiencies of your product, of the industry, and that will eventually unlock the business value out of it. Right? So if I move on, sorry, yeah. If I move on, the next topic, right, industry of the R. Let us understand what are the manufacturing mega trends, right? That has evolved over the period. As I said, we are now living in a post-COVID era. We are living in an era of lot of geopolitical dynamics, and importantly into a technology era, right? With that, how the manufacturing is shaping up. Most of you might have heard about, right, about the supply chain complexities, right, that has evolved again in the post-COVID times, right? So there is a supply chain complexity, there is a demand for short batches, there is a demand for customized products, right, where every customer, every individual customer looks for a lot of customizations, right, when it comes to a product. Then there is a demand of use of technologies into the product, right? With all of that shaping up, what does that mean? So there are multiple meanings out of it, right? If I get started with the industrial meaning of it, right? The focus is more on the resource productivity, whether it is the asset, whether it is the machines, whether it is the physical devices on the manufacturing floor, and also the human productivity, right? How do we amplify the human productivity? Then the focus is on reduced cost of operations, right? How do I build the same product with a minimum cost, impact cost, right? Direct and indirect cost, and how can I again, right, add more productivity into my production so that the cost can be balanced out. Then there is a focus on agile and lean manufacturing. When I say agile, you should have a manufacturing line which shows a lot of dynamism, which shows a lot of flexibilities, right, when it comes about the manufacturing. Eventually, apart from the factory incentives, there is a lot of focus on the quality of the product, right? So there is a greater focus on the regulatory compliance. Manoj is going to cover a lot about the digital quality and regulatory compliances, right? That is applicable primarily into batch and process industry, right? Specifically, while it do applies across the industry, right? Then apart from that, most importantly, we have to create a green earth. We are all looking to create a environment safe manufacturing practices, and that is where the focus is on reducing the carbon footprints. The focus is on environment safety and, right, necessary compliances, so that there is a limited usage of fuels that are creating, right, lot of pollutions that are, right, obviously that are bringing in, right, a lot of dynamic changes on our earth. If I move on, now how do I create a foundation, right, of an intelligent manufacturing? Well, now we have understood the manufacturing trends. Focus, I'll repeat it, right? The focus is on productivity, the focus is on quality, the focus is on reduction of cost, and finally the focus is on creating a green and repeatable manufacturing, a sustainable manufacturing world, right? With that as the background, what are the foundations for an intelligent manufacturing, right? So these are some of the statistics, as you can see, right? 3.3 million hours in a year, right, are lost due to unplanned maintenance. When I say unplanned maintenance, it means that within the industry there is a breakdown of your machines, there are downtime due to assets, there are downtime due to unavailability of labor, right? There can be multiple ways and means where there would be some downtime, right, in the factory. So 3.3 million hours are lost every year, right, due to the downtime. How can we primarily focus on reducing it or eliminate it completely? So that is the focus here. Now, if you can see the graph, right, that in the center, so you have got the direction of the industry, right? We started with industry 1.0, which is more about mechanical industry. Then it evolved to industry 2.0, which is more about bringing in machineries to the industry. Then it is industry 3.0. 3.0 is where we got computerizations, right? We got computer, we got connected to the machines, we got more control about on how the machines should function. Then the next step after computerization was connectivity, right? So how do you connect the machines? How do you ensure that the data generated out of the machines are captured, right? So that is your connectivity part of it. So that is all about what happens, right? If something is going wrong, what has happened to that? Why that has happened to that, right? So based on the connectivity, you should be able to establish the reasons around it. Then we have got the next step, which is the visibility. So once you have connectivity with your machines, with your assets, with your resources, with your processes, then it comes to the visibility part of it, right? Where you can use that connectivity framework to basically visualize on what is happening on the flow, right? Then you have got the next step, which is called transparency. Now this is a very important step, right? So transparency helps for any kind of issues. It helps to unlock multiple things. What has happened, why that has happened, and what will happen, right? So it brings in all the dynamics, all the aspects once there is an incident on why it has happened and what will happen what are the next steps that I should perform, right, to fix it. So that is all about transparency. So this is where we stop, right, with industry 3.0. Now when you move to industry 4.0, that is where the AI and Internet of Things, right, play a crucial role in shaping up industry 4.0, right? So if I say, so you have got two key aspects of industry 4.0. One is predictability and one is adaptability, right? When it comes to predictability, it is more about predicting the future of your assets, of your machines, of your resources, of your processes, right? How do I know that what I can produce tomorrow, what I can produce in the next 1 month, next 6 months? So that predictability is very important in order to meet your demand forecasting, in order to better planning, and in order to improve your efficiency. Similarly, you have got adaptability. This is the final stage, at least as of now, right? Based on all the industry analysis, this is the highest or the peak stage that the industry should achieve. So when it comes to adaptability, it means that you build a system, ecosystem of machines and assets that can fix themselves. So imagine that you have a car, right, which is running on the road, and there is some issues that comes inside the car, inside an engine of a car, and the car is able to identify the problem itself without taking it to a garage, to a mechanic. The car can identify the problem itself. The software embedded within the car, the artificial intelligence embedded within the car can identify the problem itself, and it should guide the driver, it should guide the owner on how it has to be fixed. So that is the last stage, that is called the adaptability stage. And to reach there, the focus is more on AI, ML, and as you know, AI, right, has transformed to generative AI or Gen AI, and now we are focusing on agentic AI. So the newer versions of AI bring more nuances to this, brings more perspective on how we can achieve the highest degree, which is the adaptability. So this is analysis by a well-known source, right, McKinsey, on the industry, right? They have done an industry analysis on the adoption of AI, right? So as you can see here, there is a huge belief across industry, across the globe. Almost 83% of the industries believe that AI is going to bring a rapid transformation in the way they are currently operating, are going to bring in unlock lot of efficiencies to their processes, to their assets, to the people, and eventually to the product, right? So with that, there are three focus areas, right? Again, this is my analysis. There are three key focus areas that we should look at, right, leveraging AI in the industries. One of them is quality. As you can see some of the stats here, right? PepsiCo, for example,
they reduced their labeling problems, right? You might have seen Pepsi bottles and there are labels around the bottles and all, right? So they reduced the labeling problems by over 30%, right? Using vision-based AI. So with vision-based AI, any kind of issues with labeling, it can be the expiry date, it can be a right or wrong label, it can be a label about the batches. So the quality checks, right, through vision AI help them to reduce their labeling problems by over 30%. Similarly, using AI, applied materials AMART, right, they need almost they extract almost, right, 0.001 percentage of sample data, right, that to characterize all the defects, right, for the materials. So next is your assets. So assets, we focus more on, right, predictive maintenance here. So leveraging predictive maintenance. So what is predictive maintenance first, right? So predictive maintenance basically predict the maintenance cycle of your asset, right? I will take again the car as an example. Imagine you have a car where the car gives you the instruction that it is the time to take it to a garage, to replace the engine oil, to do any kind of mechanical fixes, right? It gives you instruction well in advance with the date and with all the details on what you should do next, right? So that is your predictive maintenance of a car. Similarly, for any industry, there are a bunch of machines, there are a set of assets out there, and then you have to focus on predictive maintenance of those assets, right? So predictive maintenance, in-time predictive maintenance can reduce your downtime, your unplanned downtime by almost 20%, which is a huge number, right? So when I said, if you remember in the previous slide, I said that 3.3 million hours, right, per year are lost due to unplanned downtime. So a 20% reduction is a huge, right, when you leverage AI and predictive maintenance, right, to reduce the downtime. Similarly, when it comes to optimizations, right, most of the a key feature or a key asset, right, of any manufacturing industry is OEE, overall equipment effectiveness, right? OEE is used to measure your efficiency of production, your efficiencies in quality, and your efficiencies in terms of delivering to customers and so on. It's kind of a very hybrid way to measure your, right, key performance index. Now, most of the, as per the analysis of McKinsey, most of these manufacturing operations are at an average OEE of 70%. And now it is predicted that with use of artificial intelligence, the OEE should go all the way up by 15% to 85%. Again, this is a huge number, because as I said, OEE measures your performance, it measures your productivity, it measures your quality. So all together, getting a 15% upsurge is a huge impact, right, to the business. So I will now come to some of the use cases, all right, industry use cases leveraging artificial intelligence and Internet of Things together, right? So there are two categories here. One is the industry. Industry means, again, I saw a lot of industry, by the way, right, in my tour this morning. So industry is where your production happens, right? Whether it is a manual production, whether it is an automated production. Production is all about your industry. Then you have got a product life cycle, which is more about the product, the end product that is used by the consumer or the customers on the floor, right? So these are the two categories of use cases where we see AI and IoT together can really do the magic. Right? So convergence of AI and Internet of Things, right, will help expand the industry cases by enabling the AI devices. It brings in smarter data management, it brings in faster innovations into the industry, right? And the impact, the positive impact leveraging AI and IoT together is again bringing in operational efficiencies, bringing higher level of productivity, creating new revenue streams, right? Because you now unlock the true potential of everything that you have within the industry. Again, the people, the processes, the performance, the assets, and so on. and then eventually you bring in an enhanced customer experiences. Your time to delivery, right, exceeds your quality of the delivery, quality of the product also exceeds, and eventually bringing in the right improved customer experiences. Now when it comes to product life cycle, again the same example of a car, right, that is part of your product life cycle. In product life cycle you have got right multiple stages that I'll come in the next slide. What are the various stages of a product life cycle, and at each of this stage how AI and IoT is bringing in a dramatic change, right, to the way the product is managed and handled. So we'll see few of the industry use cases. This is not all inclusive again, but these are some of the important industry use cases that we realize on a day-to-day life, right? One is in transportation, the other one is in manufacturing, and the third one is in healthcare. These are some of the examples again that I have brought in together. When it comes to transportation, imagine that you have a system that does an effective fleet management, that brings in real-time feedback from your fleet, from your vehicles, right, your transport vehicles, directly to your command or control center, that brings in a effective view of demand forecasting, right, that will basically help you know what is your demand about your fleet, about your vehicles, right, from in terms of transportation, in terms of right supplying to your customers and so on. Then eventually it will help you to bring an improved delivery assurance with on-time delivery of your end products to the customer. Similarly, in terms of manufacturing, we already discussed a lot about predictive maintenance, right? How that helps to basically bring in the best out of your asset. There is another aspect of predictive quality, right? How can you predict the quality of a batch that is currently running on a production line, or that is yet to run or yet to start execution on the production floor, right? That is very important because that helps you to reduce your wastages. If you can predict the quality of a product well in advance based on the environment, based on the constituent sub-products, right, that goes into the assembling of product and so on. So you can eventually control the quality, the outcomes, right, that comes at the end of a run. Similarly, in healthcare, we see there is a lot of usage really in Western countries, and also in APAC, China, Singapore, and so on, right? They are catching up quickly, I mean, real fast in terms of healthcare. So there is a proactive healthcare, there is a personalized treatment. So imagine a scenario, right? So there is a person who needs immediate attention. Let's say the person who suffered some heart attack or something, and he is being transported in an ambulance, and then you have got a system in place that captures all his vital parameters, that capture all his historical records, and has already supplied all the data to the attending doctor. So the moment the patient arrives in the hospital, the doctor is aware of all his historical illness, the doctor is aware of all the medicines that he has been taking over the year, and most importantly aware of all the current vital parameters. So the treatment can be started immediately the moment he arrives into a hospital. Traditionally, as you see, or even now, right, let us take an example in Bhubaneswar. If you go to a hospital, you spend first 5 to 6 hours measuring your multiple parameters, your blood pressures, your ECGs, and so on and so forth. And after 6 hours, the doctor will diagnose the problem, then he will come to the treatment. So the entire cycle takes a day before you finally go into the OT for a treatment. But with the predictive healthcare systems, with the AI-driven healthcare systems, that time can be reduced and the chances of recovering for a patient increases significantly. Okay. So if I may move on from industry to product life cycle. So a product life cycle, when you build a product, again you imagine a car as a product. It's an easy example for everyone to understand, and that is why I'm time and again coming to that, right? So you first start with the designing the car, right? Once you start designing the car, you will understand the positioning of seat, the positioning of wheel, the length, on the front, the length on the back, right, and so on. So that is your design part. Once the design is completed, then it goes to the manufacturing, right, where the car is actually manufactured through assembling of multiple products, right, or sub-products. Then eventually it is deployed into the markets. There are consumers, right, who buy the car, who take the car in, and then finally, most important, the operations and maintenance, right. So once the car is out in the market, is industrialized, right, across the segments, how do you provide maintenance and necessary upkeep, right, of the product. So now, in a traditional setup, right, again, the design, it takes time. There are design faults. You might have heard about recalls, right, by various companies in the past, where you have design faults and there are recalls. Then you have got a manufacturing cycle, which is also, at this point, for some of the manufacturers, the cycle is as high as 3 to 6 months. Then you have got a deployment, and finally the maintenance is something which is, as of now, right, in most of the countries, like even in India, it is more manual in nature, right. Now if I bring in artificial intelligence, right, to this, then it will help me to, from a design perspective, it will help me to understand the market trends, so that I can decide on what should be the design of the car based on the demands from the consumer segments in the market, right. Then I can explore more design options, again leveraging the same data based on the consumer demands, right. I can see or create a slick design that can basically drive the attention of the consumers, right. And eventually, the most important of all of this is to build a strong consumer experience at the end of the day, right. Similarly, when it comes to building, how can I build a car? How can I do the quality check? How can I create a lot of data for checking of the quality? How can I create necessary playbooks, right, for that particular product, and so on, right. Similarly, when it comes to operations and maintenance, right, let us say we create a lot of virtual assistant that helps them to, right, maintain the product. We optimize the inventory of maintenance, because you can see, right, there has to be a neat balance between the spare parts in or the inventory, right, with each of these manufacturers, and the maintenance cycle. So how do I identify, right, the demand for the spare parts in future, right, when I am a company, or when I am an industry, right. So artificial intelligence, again based on all the historical trends, it will help you to calculate, and it will help you to understand on what are the inventories, right, that I need to maintain as part of my operations and maintenance cycle, right. So now, the impact, right, let us see the positive impact of artificial intelligence and in the Internet of Things, right, IoT together, to the industry. So we have understood through multiple examples, right, that there is an increase in operational efficiency in the factory. There is an enhanced customer experience. The previous slide I spoke about, right, on how do we understand the consumer needs, how do you understand the consumer demands in terms of design, in terms of usage, and then create a product eventually that suits their demand, right. So there is an enhanced customer experience. There are newer revenue streams for the business, right, because once there is an increase in productivity, once there is an increase in efficiency, and once there is a better market analysis, so the business can understand, right, where they can generate more revenues and what are the areas they should, right, focus on. Eventually, it brings in continuous learnings, because based on all the data collected over the period through Internet of Things, and based on the analysis of data, you can synthesize your learning process, and you can, through that continuous learning, you can bring in value to this overall chain, right, starting from design all the way to the maintenance. Then you have got faster time to market, because eventually with technology, as I said, your productivity increases, your performance increases, and hence your delivery cycle also increases rapidly, right. So finally, and most importantly, you have got a faster decision making, because earlier decision making was based on human intelligence, decision making was based on the limited data that was available. Now with artificial intelligence and Internet of Things, we have a humongous database, right, set of data, and the analysis happens in truly milliseconds, right, on that data, and that is where the decision making becomes very rapid and very faster, right, as part of the process. If I may move on to the next slide, what are the challenges? Now this is where I get back to the quotes, right, from Stephen Hawking and Elon Musk, right, that we are creating or demonizing the earth using artificial intelligence. We are all the way to end the human race. I mean, there is some value in the quotes, and what is the reason for the quotes, right? Now, when you collect huge set of data, and that data also includes personal information at times, right? So there is a important urge for cyber security, for a security of your data, because the data collection happens through internet, the data transmission happens to internet, data transmissions happen through cloud technologies and so on, right? So it is very important that the security of data is never being compromised, and there are adequate measures being taken in terms of both data collection and data transmission. Then the next important thing is, how do we manage the huge, right, the humongous data being generated out of all of this, because you have got your product which are now sensor enabled, which are now connected, which are now AI enabled. So you are getting data in every millisecond out of a product. Then you are getting data in every millisecond out of the industries. So how do you manage and maintain all this huge set of data is a challenge, is a huge challenge, right, that has to be addressed. Third important thing, interoperability, right? Interoperability basically brings in how the systems stay connected, because while there are multiple connection protocols available, right, and the kind of ways of connections have in fact increased a lot, right, but at the same time we still see challenges that there are multiple systems who face issues in terms of connectivity due to formats of the data, due to the size of data, due to the classification and category of the data. So interoperability still remains a challenge when it comes to data transmission between systems. Compliance, how do you bring compliance to the data? How do you ensure that the quality of data is again not compromised is very important, because the same data goes for an analysis. And Manoj, I think, will cover that in the next next session on pharmaceuticals, right? How compliance is important, and in fact very important, right, in the world of pharmaceuticals, in the world of consumer products and goods and food and beverage and so on, right? Finally, the ethics, privacy, these are also very important parameters, and you might have heard, right, you might have been listening to a lot of this podcast on YouTube and so on, right? A lot of these articles where people are truly concerned with the growing world of artificial intelligence. There is a huge risk to the privacy of the data. There is a huge risk in terms of ethics, because with artificial intelligence it is very difficult to even know, right, the authenticity of anything that you get over the internet. Now we'll discuss quickly discuss a life sciences use case, right, leveraging artificial intelligence. And this particular use case, I have collected it, right, this use case is from renowned hospitals, Arvind Eye Hospital, right, I think it's based out of Coimbatore, and then we have got Shankar Netralaya, you might have heard both the names, right. So this is all about, as you know, right, diabetes is a disease that eventually, or it's a metabolic disorder, right, not a disease, it's a metabolic disorder that eventually lands you upon multiple, right, diseases, which also includes the retinal failure, which also includes causing blindness and so on, right. So there is something called retinopathy that helps you to identify the stage of your eyes of a person who is diabetic and what is the condition of the retina, right. So the way it typically happens, let us keep technology aside, the way it typically happens, that you go to a specialist, he will put some drops in your eyes, he will take images of your eyes, then he will do a lot of, right, reading on those images, and eventually he will advise you on how to proceed next, or what are the next steps that you should do, right. So there are issues in terms of scale, because countries like India and China, where the population is so high, the number of specialists to the number of patients, the ratio is truly screwed up. Then you have got accessibility. There are people who are in remote villages, there are people who are in undeserved areas, and they have no access to hospital, they have no access to healthcare and so on. Then you have got a time and cost. As I said, the manual examination goes through a lot of processes, lot of images captured, then waiting for the doctor and so on. So you have to spend almost 5 to 6 hours, right, before you eventually come up with the outcome. Then finally, most important, for the same report or for the same image, if you go to two different specialists, they will have two different views, right? So the accuracy of the analysis of a human, when I say human, it's a doctor or it's a specialist, differs when it comes to, with the same image, when it comes to human processing. Now, Sankar Netralaya and Arvind Eye Hospital, right, with the help of Google, Verily and DeepMind, right, these are the Google technologies, with the help of Google, they have leveraged artificial intelligence to basically diagnose and analyze this diabetic retinopathy, right? What do? So they do a data training, which means they bring in a vast data set, humongous data sets of, right, de-identified retinal images. So there would be a huge database of retinal images, and what are the perspectives, right, for each of these images is stored in that, and they do a lot of analysis through deep machine learning and right, vision AI to eventually understand each case and each of these retina, right? Then there is a pattern recognition, again through the algorithms. So based on the images, they create a pattern on how to, right, how to basically analyze the condition of the eye or condition of the retina, right? That would be through the blood vessels that are captured through those cameras or images. Then it would be a lot of other medical parameters, right, that they check over for a retina. Then eventually the automated screening, right? So you have got retinal images, you have got fundus cameras, right, where you can capture the images of the retina, and then you have got automated screening of that, right? And then finally the prioritization. Once you do an analysis of your retina, right, through artificial intelligence, the system will suggest that what are the cases that has to be prioritized based on the severity, based on the conditions and so on. And that is how the doctors can also prioritize the treatment, right, in a similar way. So with all of this, so we have, right, this is the analysis again from the same clinic. So we have got a higher degree of accuracy, we have got a increased accessibility and efficiency, because now you don't need a specialist to take the images, to do the analysis and so on. With artificial intelligence, even the technicians on the job, they can capture the images, and then the system will do all the analysis for them, right? Then there is a reduced workload, and there is a faster diagnosis again because of the limited dependencies on the specialist, right? And finally, there is a higher accuracy, and early detection of the issue can help prevent the vision loss for the patients. If I may move on to a next use case, this is a use case for one of the largest forklift manufacturer, right? Some of you might have seen forklifts, and I just saw one right under training here. So forklift manufacturers, they want to transition to a as a service model, right? Which means they want to bring in the technology to eventually help, right, create a high quality and well precision forklifts that can be used in industries, right, on a commercial scale. So there are a few questions that they wanted to address, right? What would be the connected forklift features and capabilities? So they are more focused on a connected smart product, right? That is the category, if you do recall from the evolution, it's the third category, the smart connected product. So they wanted to create a connected forklift ecosystem. They want to consider open systems where the forklifts can connect to the internet and can connect to, right, computer commands and so on. Then they also want to see how or what are the additional features that can help, that can be added to the forklifts, right? That can help to transform their business, and eventually what is the scope and boundary of their expansion. So this was done by one of the largest forklift manufacturers, right, as part of their analysis. And then finally they came up with something called global telematics solution, a cloud-based solution, right, that enabled them for near real-time data collection, that brings in advanced dashboarding and reporting capabilities, that helps on demand, right, command and control of forklifts without human interventions, that created over the year updates of the forklifts, right, software updates of the forklifts without a connection, right, to a port or to internet, and eventually that brings in predictive maintenance, right, with artificial intelligence and machine learning and so on. So finally, what is the impact, right, they got? So the number of IoT trucks, number of smart connected trucks that they could produce are now at 5,000 trucks per month, right? There is a huge increase in the productivity. Then similarly, 15 million transactions are captured per day. So the kind of data captured for these forklifts, right? And based on that data, they do the analysis, they do the design changes, they understand the need of the hour from the consumer base and so on. So eventually using this artificial intelligence and Internet of Things, they were able to kind of, right, improve their efficiency by more than 25% and eventually the business. So finally, time to wrap up, right? If I peek into the future, where does the future lies, right? Point number one, there's a more focus on ambient computing, right? Which is bringing in improved and bespoke personalized experiences, right? Amplified personal experiences when it comes to use of a product, use of a technology. As a consumer, what is the best that I can get out of it? So with consumer demands and with the use of technology, we are looking at something called ambient computing. Next, we see there is a convergence of agentic AI and Internet of Things, right? That is an unexplored options, but it has a huge potential because agentic AI will drive the way artificial intelligence is currently being used in industries. That is again another area which industry should explore. Pervasive connectivity, connecting the ecosystems, not only the systems or devices, connecting ecosystems across the industry is something again that should be an area of focus. Then eventually, most importantly, technology for good, right? And that is where the agentic AI and IoT together can help build a technology for the good of the human being, right? To summarize what we spoke about, right? AI and IoT natural convergence, especially from an industry perspective. When we look forward to build an industry, when we look forward to achieve the maximum out of our business, so AI and IoT together should be the convergence for it. Impact on industry and product development life cycle. We understood that it brings in a massive change to the both the industry use cases as well as the product life cycle use cases, right? So use of technology can definitely help to improve the efficiencies, improve the outcomes. Agentic AI is in IoT is truly emerging, right? There are a lot of research around it going on. Some of the industries are again skeptical about the use of it, but some of the large firms are already enrolling for it, right? Especially in United States, we see a lot of use cases where agentic AI and IoT are coming together. Finally, to wrap up, we should look at technology for good, technology for humans, and eventually technology for the future. Thank you.
Can we take some questions?
Yeah, sure.
If anybody is having questions, you can ask. Can you please raise your hand if you have a question? You can go ahead.
sir, for sharing such insightful session. Your expertise in industrial transformation has given us a clear view of what intelligent manufacturing truly looks like. Next, it's my privilege to introduce Mr. Manoj Kumar Nayak, Principal Consultant IoT at Infosys Limited, Electronic City, Bangalore, who is also President of Alumni Association of Centurion University, an alumnus of Centurion University of Technology and Management's inaugural batch in 1997, a testament to the power of vision and education in shaping leaders. Mr. Nayak holds a BTech degree, PGTBA, MBL and LSSBD certifications with over 23 years of experience. He is a leading expert in pharmaceuticals, biopharma, life sciences and IT consulting with deep expertise in digital pharma transformation. His experience spans QMS, compliance, validations, global project rollouts and managing international teams. He has delivered cutting-edge IT solutions for pharma, medical devices and F&B manufacturing. Today, he will be addressing on digital quality, the engine powering smart pharmaceutical manufacturing. Please join me in welcoming Mr. Manoj Kumar Nayak. Sir, the floor is yours.
Hello friends, good morning. I think I have to start with something different actually. IoT, AI, they are making chairs and benches are also smart here. Where we will stand, isn't it? Somewhere we should stand, right? Our intelligence also should play a role. But now we are giving intelligence to immortals, in the sense the things which doesn't have life, they are getting intelligent and we are making them intelligent. That's where I wanted to take it to another topic. Smart pharma manufacturing. I'm making manufacturing smart. I'm making something intelligent which is made by me. So, if they are connecting my laptop, before that I just put a question. How many of you from pharma? If you can please raise your hand. One. Only one? B pharma, N pharma, D pharma? Only BTech, excellent. BTech biotechnology, anybody? Good. Super. BTech mechanical. Because my department is wiped off. I am from BTech Chemical Engineering. That's why I was talking to Mr. Amit while traveling that there are two sides of a coin. One is called qualification, another is called education. We are getting highly qualified, isn't it? We are getting highly qualified. I did my BTech, I did my MBA, I did my MBL, I did my LLB, I did my Six Sigma Black Belt from Germany, lot of things. But these all are qualifications. My grandpa was only SSLC, my father was BA, LLB. I have done 6 other things also with me. But when I wrote a letter to my father, he brought a Western dictionary during my engineering, telling that your English is a little poor, so you will just improve upon your English vocabulary as well as your spellings are also getting wrong. My father's father also did something with him. They were all educated. We are all getting qualified. Do you agree with me? Do you agree? We are all getting into the qualification genre. We are not getting into the education genre. So what I try to say, I am not qualified, boss. I am educated. Why? Because my branch is not there. I will speak but. Isn't it? I am a chemical engineer. I work for pharma. Now I am working for Infosys. People ask what you do. You have the same doubt? How many of you have the same doubt what I do in Infosys? How many of you are from mechanical engineering? Which engineering you are studying here? Sorry? Computer science. Excellent, excellent. So, because Infosys you people are computer science, I will speak pure functional. I will speak not the industry making smart. I will speak the smart industry, what we have. Got my point? So digital quality, the engine powering smart pharmaceutical manufacturing. I told that we are making the manufacturing smarter. We are making the machines intelligent. Because we have to be dumb. Is it so? That's what Elon Musk is trying to say. Mr. Ramesh presentation you had seen just now. Elon Musk tried to say something. That we are trying to do something which is very, very dangerous for our future. But that gives us edge over others, right? That's what I am trying to say. That this smartness brings quality is the competitive advantage. So I would like to speak about 4 things. The industry sector and pharma value chain. How many are from MBA? Any management graduates? No. Nobody. Very good. Is there? One guy is there? Huh? At least all knowledge is yours. Because no MBA guys, right? One guy is there from pharma, one guy is from MBA, and remaining everybody is from computer science. Definitely, I need computer science people because they have the backbone. But you are making others intelligent, isn't it? So, pharma regulatory framework and GXP. What is GXP? I'll just speak out. Maybe C only will know now. And smart pharma manufacturing and digital quality, the competitive edge. Application across pharma process value chain, which I just wanted to speak about. How many of you were suffered from COVID? Nobody? Great, yeah? Great. We have spent 100 crores of vaccine doses. You understand that? That helped. That helped. I am sure. Somebody told nobody was suffered from COVID, but I was. That's why I thought I'll just present something which is relevant. You know why India is called as the pharmacy of the world? India is called as the pharmacy of the world because the example was shown in 2021 and 22 where we could serve around the globe all the vaccines that was required for getting not eradicating, I think I'll just tell that getting vaccinated against this COVID virus, which helped us to live. And that's where we made ourselves as the #1 manufacturer across the globe for the pharma. So why we are called as a pharmacy of the world is because of the large scale production, affordability, global reach, and our vaccine production, which you have already proved, generic drug production and quality assurance. What is this quality assurance? What is the generic drug production? Where we are affordable, all these things we'll just discuss in a while because I'm just getting into the pharma manufacturing. Maybe I don't know if you are in life computer science, then you will not like this pharma manufacturing. Why all these things? Isn't it? How many of you have taken medicines recently? Excellent, yeah. What's your good name? Huh? Raj? Hans? I'm sorry, if I'm pronouncing or spelling your name wrong. But, okay. Mr. What medicine you have taken? Excellent. Dolo 650. How many of you know this medicine's name? Superb. I worked as a general manager for that company. I was producing that. 2013 to 2015, I was a general manager with a company called Microlabs Limited. Microlabs is producing Dolo 650. You have taken Dolo 650, correct, Nawaz? How it was looking? Excellent, excellent. I owe you. So it is a blue color strip and a white color pill. Okay? And that is, he knows that it is Dolo 650. I will remove that white color pill and from the blue color strip and give it to you. Do you know what is it cyanide or Dolo 650? Confusing, right? Anyone? You told that you have taken Dolo 650. Dolo 650 was there and a blue color strip, inside that there was a white color pill. Oval shape, of course, because 650 mg is the strength, it is a little bigger. I was only producing that actually. So I was in charge of that actually. Don't take other way because people can think other way also. So what I mean to say, you have taken Dolo 650, you know that it's a blue color strip and white color pill, and of course it was written on that Dolo 650 as well. We are not done. But if I remove that, even if it is written Dolo 650, Dolo 650 is having the constituent or the API called paracetamol. And paracetamol 650 mg is there inside. How do you know that? Sorry? Can anyone tell how do you know that paracetamol is there in that tablet? It is not chalk powder. You agree that? Excellent. Excellent. This is what I want. It was written on that strip. It was written on that. We are computer science guy, I think, correct? Not pharma, I agree. Don't worry, but you have the right answer with you. It was written in that. If that written is, do you agree that whatever is written that is there inside? It should be, yeah, you are right. It should be. Who doesn't allow? What is ITC? See, you are coming to the point. As a human being, Mr. Amit told me just now in 2 hours that he was Shankar Netralaya. They go and they'll put 2 drops of eye drops when you go for an eye checkup. Any of you have gone through this? But I was in charge of another product called Gedifloxacin, which is for red eye disease. I had that suffering. My left eye was red, and you can sit down, boss. You can sit down, please. Thanks. I was having my red eye, and I took that from the production because where it was getting manufactured, it was lakhs of bottles are available. I went there, and it was an approved product. I took that vial. I put 2 drops in my 2 eyes because I was the in charge, right? I was the quality head, and suddenly I saw my eyes are getting blood red in 1 hour. Did I do something wrong? Because it was for, I was right. So when I interviewed the guy who was manufacturing that in my team, he told me, sir, this medicine is for different market. It is having a different dose. It's not for India. That dose when I took, it was difficult for me to digest, difficult for my eye to make it sensitized. Think If that drop of 2 drops which I put, that drop when you put, do you know that is gadifloxacin? By seeing that you can tell that? By seeing a tablet, can you tell that it is paracetamol? It is dose 650? By seeing that drop, that 2 drops can be drops of acid, right? If they have the drops of acid, what is the situation of our eyes? By seeing the bottle written on that, can you believe that what is there inside? Can you believe? Only people can tell by seeing that bottle, Rajinikanth or God. Nobody other than that can tell that what is there by seeing, by visualizing, by just seeing a drop of water, a drop of the eye drop which you are putting in, a tablet or pill which you are eating. By seeing that by visual observation, only few people can tell, but this is humanly impossible to tell. If those 2 drops are drops of acid, then eyes are gone. If that drug or medicine which you are eating, it is having few milligrams of rather micrograms of cyanide in it, then you are gone, you are out. How do you believe? Who does that? What makes you confident? What makes the layman confident that this is the medicine, what it is written, it is there inside? That's called quality system. Understood? Why I had to bring it to you is, being a layman, see once what happened, there was a guy, he got suffering and he fell down. He was having a cut, he had been taken to a hospital, and suddenly he told that we have to put some antibiotics for one day, and he has lost a lot of blood. He has to be there under intravenous in the sense they put it in the vein and they give all the medicines to the vein. In the sense you have seen the saline and all. The saline bottle is connected to him. He was working for a pharma company. And that saline bottle was manufactured in his pharma company. It was put to him. Suddenly when he was awake and he was fresh after 4 hours, he saw that that bottle he put is from his company only. He removed it. Why the hell you are putting it to me? I only produced that. Then what is the problem? I know how it is produced, he is telling. They are not up to the mark. That's why it's mandatory to follow certain rules, certain regulations, certain systems, quality systems. Exactly, that's why the pharma and life sciences industry is very, very much regulated and controlled by quality systems. That's what we wanted to talk now. I have taken much time to make you take through. Now, any one of us who are studying here, whether you are from any branch of studies, you have to either work for yourself or work for others' business. Either you have to work for yourself, you make your own business, may you call that as a startup or sit down or whatever. You make your business or you work for others' business, isn't it? So when you work for your business or you are working for others' business, you should be a skilled person to know where you are working. So what is the genre, what is the scope of work? Where do you want to work? You want to work in an industry, right? So I just wanted to bring up on here, what is an industry? Like if you see, there are sectors, primary sector, secondary sector, tertiary sector and quaternary sector. Where primary sectors are like farming, mining, fishing, which is directly connected to the earth. You can work there also. You can be IT head of a mining company. You can IT head of a farming company, agricultural product making company. You are a BTech computer science or you are a pharmacy graduate or you are an MBA. You can work as IT head of that, right? You can work as a sales head of them, right? So the primary industries are the industry which is connected with the earth. We directly, we just make something out of the earth, Mother Nature. And the secondary industry is called, the secondary sector is called the manufacturing sector. Out of this, suppose ore is produced in mine, that the raw ore is taken and converted that into a usable product. That's where the manufacturing industry comes into picture. Third type is the service industry, who helps them to grow, who helps them to enable them rather. The manufacturing gets enabled, right? And for example, IT, banking, retail, entertainment, these are enablers. They are all service sector industries. The fourth is knowledge sector, where I am standing today. Knowledge lies here, and the university actually, isn't it? So this is the knowledge sector. You are knowledge heroes. Sirs are sitting here. Who gives you knowledge? They have dedicated themselves for getting the knowledge, and that's also paid, isn't it? So that's your skill, and there also you are paid. That's also an industry. Now, I am talking about the pharma industry, which is coming under the manufacturing sector. You need to know when you are getting into the job tomorrow after fourth year, which industry you are working. 99% people will not. I am working in Java, I am working in Python, I am working in some pharmaceutical manufacturing company, which report quality control. I am working in some MBA is telling that I am working as a sales executive, sales head. But which industry? Which domain? Which function? You need to know, right? That's why we are into the pharma manufacturing, and the manufacturing industry is again categorized into 5 sections. There are different kinds of manufacturing: process manufacturing, discrete manufacturing, dedicated manufacturing, and bespoke manufacturing. We are here doing many manufacturings. What we have gone through also, Mr. Ratha also told, he has already detailed about that. If it is a process manufacturing like pharma, beverage, dairy, soaps, they are called process manufacturing. Also, metal processing, oil refineries are also process manufacturing, but they are continuous process, and these are batch processing. So process industry is having 2 sections: batch manufacturing and continuous manufacturing. Similarly, discrete manufacturing, automobiles, smartphones and all, where each component is a finished product that gets combined to give you a final finished product, which is used by the user. They are called discrete. And the repetitive manufacturing, which is like in the same line, with the same taste, with the same product when you are producing repeatedly, like Coca-Cola, line is same. And it's a process, that it's repeated process. Then the bespoke systems like project, some chemical paint, mining, so which I have given an example. These are the basic things. Why I wanted to bring it up on is, pharmaceutical industry is a secondary or manufacturing sector which follows mostly batch manufacturing process approach. That's what I wanted to tell. Batch manufacturing process. Why? There also we can put IOT. There also we can put ARVR. There also you can put RPA. There also you can just go for all the data to control in the cloud. There also you can get into the big data, where the data can be controlling and giving the process the robust feature. That's what we will just be speaking about. Now the pharma process value chain. Process means how a product is being produced in pharma, how it comes to market. If you see vaccines in COVID, somebody told nobody is diagnosed with COVID positive. I am happy for that, but there was a product which was having only 1 day shelf life. If you have seen, those who have given the vaccine on that day, that bottle will be opened by calling all 10 people together, because the shelf life is only 4 hours. After 4 hours, it will turn into poison. If you don't give that drug injected within 4 hours, after 4 hours that drug is getting poisoned. That is creating some other impurity, which can be carcinogenic, which can cancer to you, which can be gene mutating. It can just mutate your genes. So that's the way it is. That's why I am just getting into the complete phase how it goes. Discovery, research and discovery, then clinical development, pharmaceutical manufacturing and supply chain, then launch of the product in commercially, and post-market surveillance and patient support, that is customer complaint and return goods. When a drug is failed, its stability. Suppose again I am asking the person who has taken that Dolo 650, what is the shelf life of that? When manufacturing and expiry date was there in that, right? I guess 4 years, 3 years. So a drug is being evaluated for its shelf life. It is 4 years means it should have 4 years plus 1.5 when it is in 2 to 5 degrees centigrade. It is 4 years plus 6 months when it is minus 20 degrees centigrade. It is 4 years plus 3 months when it is deep freeze point. Some of the cancerous drugs. So when you get into this self-life mode, that's why clinical trial is very, very important. When you do the research, discovery and clinical development, pharmaceutical manufacturing and commercialization, when it goes to commercial, same thing happened with our this COVID vaccine. Again and again I'm going to COVID vaccine because that was the very, very good example. Within 1 month, see, generally a drug production takes 7 to 9 years. Sometimes it goes beyond 15 years. But COVID vaccine was given to us by discovering and making its clinical studies, establishing its stability data, then given, injected to us within 3 to 6 months. That's why the shelf life was given only 1 day. Not 1 day, even 4 hours. Whereas Dolo 650 is having 36 months because that was established. It is not established. Established means once it is given, it clinically proven. That's why this is the complete value chain. Value chain in the sense how the raw material or the discovered product goes and takes the post-market surveillance. You are the consumer. Like that fellow who was having that injection, he prepared. So consumer can be you. When you are working for a manufacturing company, you are computer science guys or some other guys who are there again and again because a lot of people are fighting it from the same branch. So don't take me wrong. Why I am telling that? You can be a head of a pharma company. They are well paid boss. You can be head of an IT of a pharma company. An Indian conglomerate in the US or anywhere on the globe. All 200 countries are having people and they need drugs, they need medicines. That's why you can be part of it. You can be part of the drug discovery where AI ML experts are being required. Instead of 9 years, they are producing in 6 to 9 months. We are just working with some kind of company now. We are working for few molecules to file. So now manufacturing value chain, I have shown you the complete pharma. In pharma, again I am going to this area where this is the manufacturing and supply chain area where I am now concentrating today. Because manufacturing value chain, what is manufacturing? Computer chips, nowadays everybody is around this semiconductors, right? Everybody is around semiconductors. Semiconductor, how to manufacture. India is going to be the hub of semiconductors, and we are going to get the jobs into that, and we are going to get some kind of skills here which will be useful for that industry. Isn't it? So when you are going for that, any manufacturing anything, whether it is chai or whether it is drug, there is some input, there is some process, the output. Manufacturing means input, process and output. So here input, what are the inputs you have to give for anything, any manufacturing? Either they are called 5 M's: men, machine, material, method and mother nature. Any input, any chai banao, you go and make tea. You require men, people. You require machine, stove or electrical cooker. You require method, first chai, upar chini or some the flow. And you need the method to know whether it is boiled properly, how much time it will take and where it will go. And you need the mother nature. You should cook it in kitchen, not here. There is some requirements are there where So, manufacturing value chain is input, process and output. And input is what I am just trying to say, there are 5 M's: men, machine, method, material, mother nature. Mother nature is the environment which I trying to show. And the process. Next is the process. Some process you have to do, then the output will come. So that process part in pharmaceutical, because I am just concentrating today on pharma manufacturing, it is having two processes. One is synthetic, second is biotic. Synthetic is which is the chemicals. Earlier our babas, in the sense babas means not, don't get into father's zone. Babas means that babas, Om Swaha babas. Those babas, what they used to do, they used to give some elixirs, in the sense jadi buti. That used to help us. Now also that is helping. That is the root for these medicines. But that Baba can give jadi buti to 700 crore people around the world. He cannot give second time to his wife or his kids. When we want in mass production, we are 1.2 billion, 1.4 billion now. We have to eat everyone. How to produce that? Though the source is that, we have to produce that, right, in a mass scale. For that, the real chemical behind that we need to know. And that is being synthesized in a laboratory. That synthesis is getting translated and getting into the mass scale. When you get into the mass scale, that chemical reaction, that synthesis is only playing a role where we all engineers work, including pharmacists. Because making drug or making manufacturing has 3 phases: art of doing, science of doing, technology of doing. Most of you know art of doing, chai. But you do not know what is science of doing, the science of getting into the chai form. Then if you get into the technology of doing that chai form, then automatically chai also an artificial intelligence, it will be produced in few days at a time, because if you give daily data to it, automatically it will give milk, mix required amount of sugar or whatever sweetener you want, and it will produce into ilaichi, whatever you want to do and give it to you. It will press automatically. You need not to do anything. We are making smarter the machines. We are making buildings intelligent. That's why what I tried to say, the process, the output will be, in case of pharma, there are 2 things. One is called API, another is called formulation. See, why I am quality system I am just talking about is, when you produce this, in the input material you have to check something. You have to ensure something, that the sugar should be sugar. It looks like sugar, but it is not sugar. That will not give you tea. That is called critical material attribute, which goes inside. And in the synthetic process or biotic process, I just told you synthetic process, how the chemicals are getting, and the biotic process. See, now vaccine, again I am getting into the vaccine. Vaccine is produced out of the virus, the dead virus, which instills in our body to activate our antibodies. Maybe these are like little bouncing with the computer science people at all, but you can be head of computer, any of the pharma company. Again, I am telling you, can be head of IT for any of the pharma company. They are giving in crores, but you should be capable enough to grab it. You should be capable enough to grab it. They are giving crores per annum. Okay? What I am trying to say again here, so the process is biotic. When you are getting biotic, the same little one virus, you just have to expand it, and you have to make it to 1 lakh liters, from 1 ml to 1 lakh liters. From 1 lakh liters you do the protein synthesis, get the protein out of it. That protein is our medicine. That's what you need to eat to get out of our diseases, isn't it? So that's where we need the critical process parameters. So you are making that 1 liter to 100 liter, 100 liter to 1000 liter, 1000 liter to 1 lakh liter. They are bigger reactors, bigger vessels, bigger. So the parameters like temperature, pressure, oxygen content, and the humidity, whatever is working outside, and the pressure inside, all are different. It may blast. Recently it happened in Hyderabad. One blast happened in a reactor and 7 people have died on spot. Because the pressure was not controlled, the pressure relieving valve got stopped. You people are working here in the manufacturing plant, and that's what we are designing for all computer science guys again. The valve is having these all parameters. You take those parameters and make it a smart sensor, which will take all of them, and make it smart and intelligent. That intelligent smart sensor will work around and it will prevent. That's predicting, right? That's what predicting. That's where these are called critical process parameters. Any process is having critical process parameters. Overboiling of milk is also a problem. Overboiling of rice is also a problem. But there is a critical process parameter for everyone, all of them. Then comes the CQA. What is the final output you want? Critical quality attribute. That's where this is called the design space. You make what is the critical material quality you want, what is the in-process or process quality you wanted to maintain, and so that it will give you the final quality of the product which you desire. That is called QTTP, Quality Targeted Product Profile. That's where you have this quality by design approach. That should be from the raw material. Quality doesn't come at the end. I'm telling, if you are studying 4 years properly, from the writing the last exam it will make you an engineer. It will not make you a quality engineer, for sure. You will be qualified, you will not be educated. Again, for sure. That's why, if you have any doubt, you can challenge me anytime. But last 15 minutes is yours. Quality by design. What I'm trying to say, quality by design. These are the concepts. Is called quality by design. Anything you manufacture, anything. Input should be controlled with quality, that is parameters. Process should be controlled by quality, and the final product also should be controlled by quality. Originally, quality is imbibed from the input, and the final product will get the desired quality, whatever you want. Why iPhones are so good, yeah? No phones are matching it till date. Why MacBooks are so prominent? Nobody is matching it. Quality. Quality plays the game. Then, if you see the whole manufacturing value chain, it comes from manufacturing, warehousing, manufacturing, testing, and final product. Anything, any product you do, manufacturing. There will be a warehousing, there will be a manufacturing plant, there will be testing, and there will be final product. The warehouses, all the material when it is tested, they are called raw material and packing material testing. Anything raw, this is input material. And the manufacturing, during manufacturing we check in process. Rice जब boil होता है, when rice is getting boiled in a bowl, you check intermittently, right, whether it is completing or not. That is called in process check. But the rice should be good, right? That is, the rice should be of good quality. Whether it is diaphyte which we produce or not, I don't know nowadays. Diaphyte rice maybe is good for racemic index. That's what our QTTP. My racemic index should be very low. That's what I want, the final product. Isn't it? That's where my eyes comes out. So we need to have a design process. Blindly you can give. That's where AI plays also role. If the process is not fixed, AI will not play the role. Boss. Data will automatically go. It will automatically get. When you are removing, that is the final product. When you are removing, that is the final product. Then only it will create a model. Then it will give you the Gen AI approach, where you can blindly type in chat GPT or whatever, that is making industry, in the sense this building smart but making us dumb. So that's what called quality by design. In the US FDA, there is an US FDA system which is called, there are 6 systems available called quality system, production system, facilitated equipment, laboratory control system, material system, and packaging systems. These are the 6 systems, but 5 systems are interrelated, which is governed, which is taken over by a system called quality system. Quality system is having its governance across all 5 systems. That's why quality system is very, very important. pharma manufacturing workflows I try to put, pharma manufacturing happens in two ways actually. One is an API, one is a formulation. API is input to the formulation. Formulation is what we eat, what we use. It can be OSD, it can be OLD, it can be injectables, it can be inserts, it can be sprays, it can be gels. Tablets are called OSDs, oral solid doses. Liquids are called OLDs, oral liquid doses. Injectables, eye drops, sprays, everything is called pharmaceutical doses form, different dosage forms. But for all of them, they are called formulations. Whereas the input to that is called an active pharmaceutical ingredient, which is the base for curing the disease. So if you see the pharma API is having two types of manufacturing. One is chemical synthesis and biotech manufacturing, which I told. And formulation, already I have explained you that OSD, how the tablets is getting manufactured. Tablet, when you are making the tablet, it is having two things. One is the API, others are excipient. Because the drug should be stable, right? He told that he has taken $650, but he is not able to identify what is $650. It can be a cyanide tablet as well. Isn't it? So to confirm that, there is a system in place. And that system is called GMP system or quality system. And with this formulation, whatever is going inside, this drug API plus excipients, which makes that to stable for 360 or in the sense 1 year, 2 years, 3 years. Similarly, if you see formulations, cell line goes to the cell culture, then it goes to the prefiltration, sterilization, bioreactor, primary and secondary filtration, which is called upstream. What happens, from cells also we produce drugs. From chemicals also we produce drugs. When you produce from cells, there are two things. One is called upstream, one is called downstream. Those are biotech guys. I don't know, nobody I am finding biotech. But again, I am telling you, computer guys, you can be a head of biotech also sometimes, okay? Never think that, you be educated, don't be qualified only in computers. Because tomorrow if one offer comes, madam, 1 crore per annum, this computer guy will not go for a pharma company? Thank you, madam. Thanks for that. I rightly recognized. Absolutely good. Absolutely. Advanced microbiology?
Yes.
Excellent. Excellent. Appreciated. Because I didn't find anyone other than that girl who is a pharma guy. Thank you, sir. Thanks for joining that. So what I try to say is, our processing, when you produce a drug, we are crossing or closing our learning in universities only at discovery. When you go to, but we are working for pharma manufacturing, biotech manufacturing. We are knowing only discovery, we are going for working somewhere else. That's where I wanted to tell you, there are different manufacturing processes which you want to know. One is API manufacturing in these two, and formulations are basically like OSD, OLD, which is not a powder, which is not the input only. They are called formulations, which are consumable, which can be consumed. Similarly, if you biotech product, whether it is a virus cell line, or whether it is a fungus cell line, or whether it is a bacteria cell line, you take that, use from that, from thawing, from the cell line, cell bank, you take it to the, what you call, seeding. When you seed, then you go for fermentation. From 1 ml to 100 ml, 100 ml to 1 liter, 1 liter to 100 liters, 100 to 1000, 1000 to 1 lakh liters. I was making a batch of 1 lakh liter in Biocon. I was working as a director with Biocon sometimes back. So I made batches with 1 lakh liters as my fermentation cell. From where I was just getting the protein, because I have to synthesize that, I have to get the protein out. And after that I filter that out and I'll make drying, and it can be a freeze drying sometimes, it can be a free drying sometimes. And after drying I just make the drug. Oh, sorry. But the mic So that's where I am just trying to sell that biotech and this synthetic drugs. Why quality, why GMP? I asked here already. Correct, no? Do you think quality is needed? Do you think quality is needed? नहीं चाहिए? नहीं चाहिए? अरे यार cyanide खाएगा तू $650 के? How do you know whether that white tablet is cyanide or $650 by visually only? Rajinikanth or God can only identify. Nobody can identify by seeing visually. By seeing visually, can you identify what is the medicine it is? It is written on that sheet. That sheet is different. Chalk powder is there inside in Bihar. Sorry, if somebody is from Bihar, I am not offending you. I found it. I have it. In my kitty, I can share the case study. They are all Gaham Chuna. Understood? Wheat powder, looking like Dolo 650 with bleached. It doesn't go. You eat for 23 days, your fever is remaining at stack. It doesn't go down because you are eating something which is not supposed to be. It is written Dolo 650. That's why quality of the company which produces it is very, very important. It should follow a system. What is that system is called? Good manufacturing practices. That system in pharma is called good manufacturing practices. What is a good manufacturing practices? Good manufacturing practices is a system for ensuring that the products are consistently produced and controlled according to the quality standards. Quality standards of different countries are different again. If you are selling in the US and Africa, they are eating 150 mg, they are eating 350 mg. Same thing happened with me when I put that gatifloxacin in my eye. It was for Africa, double dose. My eye is gone actually. I was the head of quality. That's where, so what is quality then? Quality refers to the drug's ability to consistently meet its intended use. Consistently. एक tablet अच्छा हो के दूसरा tablet गया तो दूसरा आदमी मर गया. Consistently, it should give and meets its predefined specifications. I just told why GMP is required, which consumers usually cannot detect through smell, touch, sight. देख के अब अगर सूंघ के बता सकते हो कि this is paracetamol, I will give you 10 tablets now and tell me what is paracetamol. I will mix only one cyanide tablet in that. I will take 10 tablets, madam, and I'll just looking similar. I'll put one cyanide tablet, just by smelling, touching, or seeing, you can tell me what is that. Nobody can, as a layman. I told you again, star mark, conditions apply, only Rajinikanth are God. So what are these regulations with different countries? When you go for US, they have their regulations, they are called Code of Federal Regulations. When you go for, specifically for India, when you want to sell in India, it is called Central Drug Standards Control Organization, and our guidance document is called Schedule M. Drugs and Cosmetics Act 1945 is our guidance document, where it is written how to manufacture. What are the 6 systems to be followed? How the area should look like beautiful light and AC will not work. There should be particle count to be controlled inside, temperature to be controlled inside, humidity to be controlled inside. People cannot be coming just like that. One hair found in one tablet, whole bag should be returned back or dumped in Arabian Sea. We cannot reprocess it again. That's why you need to be, see what I am trying to say is, it is very, very critical. Similarly, every country has its own regulations. That's why every country's regulations are to be followed when you are producing a drug in the single manufacturing facility. Manufacturing facility एक है, that produces for US with different specifications, that produces for Europe with different specifications, that produces for Australia different specifications, that produces for India and Africa different specifications. I am not comparing India and Africa here, India or Africa. Okay. Similarly, issuing there are GMP issuing bodies, guidance bodies are also there called International Conference on Harmonization and Pharmaceutical Inspection Cooperation. Moreover, WHO. When WHO is the guidance, releases a guidance document, it needs to be followed around the globe. 197 countries, maybe 200 countries. So what are the GMP rules? What they follow in this GMP? They tell that get the facility designed right from the start. Quality by design. Facility design, not product design. Facility also should be designed accordingly. Validate the process. Write good procedures and follow them. Identify who does what. Who is prepared. Tomorrow a person has died by eating or by giving one injection, that is a chemotherapy, sir. That is chemo drug has some violations and it is giving some other impurity which is gene mutating. A boy can be a girl. It's a gene mutating. You will convert it to a girl. In the sense, that kind of features will develop. So those things, if somebody has done, who has done that batch, who is that, what do you call, guy who did this nuisance, we do not know means we are giving some chance to again happen. That's why there is a rule requirement that identify who does that. And keep good records, train the staff, practice good hygiene, maintain facilities and equipment, and build quality into whole product life cycle and perform regular audits, because the system should be followed. Regular audits are required. Outcome is why GMPs to be followed: produce quality products, assures identity, strength, quality and purity of the drug, building quality to product rather than testing the quality. Finally we will tell that everything will produce, finally we will test. No, राइस हम देखेंगे नहीं, लास्ट को जाके बोलेंगे हो गया निकाल दो यार, ये प्रेशर कुकर में नहीं बैठा यार, प्रेशर कुकर में बैठा है तो भी आप correct process, you have to just give the right process to it, you have to put right water, I don't know how it happens generally, and it's a legal compliance. Legal compliance, how many of you heard the name of the company called Ranbaxy? Ranbaxy सुने हो नाम? That is the only Indian MNC which was having global footprint. The company is no more. Ranbaxy is no more. $47 billion company because of its violations and legal actions. It's called data integrity. So I'll just teach you. Maybe I'll just go a little further. So what are these regulations? Basic research, drug discovery, and disease discovery, drug discovery. Until that, there is no regulations required. You can just do it in the laboratory, which you are doing in universities. But preclinical, clinical, and manufacturing APIs, there we need these GMPs, GCPs, good clinical practices and good laboratory practices. You got bored here, only pharma manufacturing, drug and all, isn't it? Now, we will get into cloud. Cloud means Azure and AWS, I am talking about, not Air, isn't it? So, the quality management system components, I told you why quality is important, why pharma quality is specifically important, because the consumer can be you can die, even it's me. And third is, now what are the components which control the system, that is called GMP. What are these GMPs? What is this good manufacturing practices? They are basically these systems like change management system, deviation management system, CAPA, risk assessments. CAPA is corrective action and preventive action. Market complaints, vendor qualification, audit management and training and document. It will just fly off sometimes if you are not from pharma or biotech. But when you do a quality system approach, these all are mandatory actually. If these systems are not there, they all are developed through Java, and the front end is something done with different, earlier it was to be .NET, now it is to be different applications which you want to find, which is convenient with the web applications. And the back end anyways, it's all databases, Oracle and SQL. But CAPA is a system, deviation management is a system, change control is a system, they have their workflows, they are designed and they are developed, they are programmed. That's where the quality product is coming as a digital product. And if you see the ISS tag, which is telling, so suppose there is a pharma company, or in this company also, there is a sensor which senses temperature. That tells that next level PLC that you should start the pump for cooling or start the compressor for cooling. Once that cooling happens, it gives a SCADA, there is another layer. The supervisor controller data acquisition that acquires the data and tells that because of that the other room should get started, other rooms should start working, other rooms compressor should start working rather. After that what happens, inside that there is a manufacturing machine, because of this temperature that is not starting, because there is a link. If the temperature is that much reached in the room, then only the machine will start. There is already program inside the PLC of that machine, and which is controlled through, earlier it used to be wired, hardwired, coded. Now it is everything through IOT. You need not to go and connect. It should be smart enough to know. By design it is smart. Similarly, when you go with this quality systems, that is level 3, which connects with MES. MES means what Amit was just telling, manufacturing execution system, and LIMS, laboratory information system, and the DMS, documentation management system, training and all. Training management system, that is called LMS. These all systems are being made now. Earlier it used to be written in pen and paper, now everything is digital. Paperless office, paperless manufacturing, paperless laboratory, lab of the future. In few places where repetitive works are coming, we are putting some RPA, some chatbot. If something like we have to ensure every time when we manufacture the vessel is clean, the reactor is clean, we are putting some AR VR. It takes a picture, it keeps in a library. Whenever that step comes, it refers to that picture and tells that this is matching or not. Every tablet, capsule, vial, ampule, injection to be verified, checked visually for any cosmetic defect. That is being done now by AR VR. So what I try to say, every place, those where I am talking, those I am telling you about the pharma manufacturing or quality system, everywhere next gen or new gen technologies are being utilized, which is relevant to industry 4.0. So in line with the industry 4.0, if you get into the pharma 4.0, here one thing is coming, digital maturity and data integrity by design. What is digital maturity? Amit has already explained maybe how it goes from earlier it was human, only person was pulling water or pulling water by a bucket, putting a rope to it. Later, mechanization happened. If only person was doing, then mechanization happened, one pulley came. Isn't it? Then automation came, motor. Now connected machines came. In the sense, the motor is there, tank is there. On the tank, in the tank there is a sensor. If power goes, it automatically goes. Until the well is dry, it will pump. In the sense, what I try to say, when you are getting into the different levels of maturity, that is called, you need to know what is the maturity of that particular pharma industry. Pharma industry maturity model is running around 4 pillars, which is given here. One is resources, information system, culture, and if you see the organization and processes. Organization and processes we can do. What is, how to imbibe culture in the development. Culture is a systemic issue. That is the biggest virus. If you do not know how to go inside a pharma company, how to stand inside, how to work inside, how to manufacture inside, how to test inside the pharmaceutical company, then you are not fit to be there. That's why the culture should be changed to make the resources digitized, or resources advanced, resources mature, resources smart. Smart resources they need now. Above all, everything data is the new oil. Everything runs around data. Data means, now I told you Ranbaxy, data integrity is the main cause by which Ranbaxy is no more today. That's why we have studied, we have learned today, we have understood today that quality by design is very, very critical. It starts from the beginning. But now I am telling, data integrity by design is equally important. If data is mismatched, you went to blood test, today morning I went there for our OHC, or somewhere there is a scan, there is a machine, and that is also a life science machine which takes blood test report. Instead of Manoj Kumar, in the sense Nayak, some Manoj Kumar Nayak's report came to me. I am cancer affected, he is telling. I went to somewhere, he went, I am just giving an example, don't see me like that. I have nothing like that. I am just giving an example, please. So what I am trying to tell is, see, one batch is released. This batch is pure. It doesn't have an impurity. and you can eat, you can give it to kids of 6 days, 3 days, 9 days kid. You are giving your 9 days kid. He doesn't know, he or she doesn't know that whatever they came. 9th day, 4th day only they started putting that medicine. And that is externally produced in the laboratory. I produced. You produced. Be careful. Consumer can be you or your relatives. When you are working in pharma, whether you are working for manufacturing, pharma production, or pharma IT, pharma anything. Whether you are a resource, whether you are into culture, whether you are into IT systems, or whether you are into anything, organizational processes, you are responsible. When this maturity comes, then the maturity level of pharma goes little up. That's called the level of maturity. And data integrity by design. What is this data integrity? Everything is data. Data integrity by design is coined by a term called ALCOA plus. In pharma especially, it's all across. What is ALCOA? A stands for attributable, L stands for legible, C stands for contemporaneous, O stands for original, and A stands for accurate. Similarly, plus is CCEA, complete, consistent, endurance, and available. What is this? The data which you are producing. A batch is produced, a batch manufacturing record is there. Step 1 to put this, step 2 to put this, step 3 maintain temperature this much, step 4 the production is done, step 5 check for in process, step 6 if not boil another 7 hours, step 8 filter it, step 9 dry it, step 10 bake it. This is who baked, when baked, who did, when did, everything needs to be recorded. If the recording is wrong, earlier what they used to do, they used to do it in a bucket because mechanization was not done earlier. And I went for tea. 9 o'clock I added that material. I went for tea, I came back by 11:30 with all gossip. And I wrote 9:30 I added. That is not contemporaneous. I added, I told that you are there, no, you write your name. That is not attributable. Attributable means who did, his name should be there. Legible means whatever is written that should be available. And contemporary means when you do write at that same time. Original, accurate. Original means you cannot write after going through and coming from T. Accurate, right? 10.1. He writes 10.1 is 10.10. Somebody writes 10.1. Somebody writes 10 .1. That is not valid. Whatever is showing there, same thing to be written. Similarly, it should be complete. It should be consistent, enduring, and available. This is of the data. Because your name can be changed with a patient who is not you. Your name can be changed with a patient for which the report is produced. It's not you, but you will be diagnosed with that. Similarly, a batch is released, but your record, you think of your record, whatever you are writing in your laboratory. If you are writing a record where that data, whatever you are writing is not for you, then, but you are signing, you are responsible, right? That's why, what I try to say, this is one of the major things for which this Rambax's program, you know what, there is a book called Battle of Lies, that is written for only Rambax's episode. What happened? There was I'll just tell an example, don't take it into a fear psycho, in the sense, when I tell that drugs can be, tomorrow you will stop eating some medicines, will be the problem. Industry will go down. So you should eat medicines, don't worry. But point is, that medicine when you are eating, you need to ensure that they are from some standard companies where GMPs are followed, where quality systems are followed. Otherwise you will get atta, chalk powder, no doubt. So nowadays it is being stopped because everybody is working around and all. A run batch is stopped because, see, one batch is produced, it was failing. But they had an emergency to sell it to US. And it was around 73 crore, in the sense some huge amount per batch. 10 batches had to go. Per batch some amount, 10 batches had to go. In 10 batches, 3 batches were not meeting. But it is in the border case. In the sense, purity should be 99.1. That was showing 99.17. Sorry, 90.17. So little less, like 90.71, I'm sorry. So they converted it into 91%. But because of the moving average of the machine where they are tested, that machine shown it is rejected. They have cleared this and that is being consumed in few of the countries, same product. Some adverse reactions are also recorded. And people suffer for that. There is a thalidomide, you heard of the name thalidomide, the drug, which was made for morning sickness of pregnant women. In the 1960s, it was a blockbuster in the US. But all women, those who were pregnant from 3 months to 9 months, they started taking because to avoid the morning sickness. And it is heart-touching that 900 babies born with deformed arms, deformed limbs. The drug was not clinically proven, not clinically fully tested, not clinically accepted by few of the regulatory agencies. With limited testing it was given and 900 and odd limbless babies, deformed babies. Thalidomide. That's why it is very critical because quality system is very, very important and pharmaceutical quality system is much more important. Digitization is of importance gives us edge over anything and everything. And it's all digitization means what they are actually? It's all dealing with data, right? Data is the new word, what I'm trying to say. Data should be meeting with the algorithms. And when it is an electronic record, the pen and paper record, you write in pen and paper. When it is an electronic record, it needs to meet few of the requirements as per 21 Code of for Federal Regulations 11 and this Annex 11, which tells that it should be it should be validated, it should be audit trial enabled. Audit trial means who did, when did, it should, and why it did, why he did it. Then it should be rule-based access, who is having the access, and who is authorized to do that. Electronic batch record and data retention, electronic signatures, who did. Electronic signatures are equivalent to manual signatures. Every record should have this. That digital data access and backup and restore. Every data should be backed up because as long as the shelf life of the drug is there, that the data of the batch should be available. If some adverse reaction comes, if the drug comes back, if a customer complaint comes, that data should be tracked back. It is mandatory, it's a requirement. If it is not there, then you are having punishable offense, just like what happened with Ranbaxy called back 170 batches, each batch of 100 crores, and they stopped production. Nobody could take. They give them the consent decree, not warning letter. Consent decree means they stopped bad production. It was one of the biggest pharma company in India, which was having global presence with $48 billion revenue. That is stopped. Name is itself not there. Now Ranbaxy converted to Sun Pharma, and Ranbaxy sold to Daiichi Sankyo initially. It went to Japan, then it went to Sun Pharma. It is closed now. That's what I wanted to tell that GMP regulations, ES regulations, SDLC methodology, this processes and all. Now, what is the digital cure? If you do this quality management system, whatever I am telling you, the lesson systems, then how it will impact? If they are set, we have quality by design approach fixed. We followed all GMPs. We follow the data integrity principles of Alcoa, and we manufacture things which all are good for all of us. And we can eat, we can safely tell that whatever is written that is there inside. Then end-to-end quality control and assurance, data-driven continuous improvement. So in the sense, data analytics and automated quality testings can be also done. That is called PAT, process automation technology. In the sense, which is now it's long back it's running, but in India it's difficult because people are there. No, why? People are there, right? People are cheaper than AI. That's why no AI. And we're still surviving. Regulatory compliance and standard alignments, seamless integration with other systems, MES, LIMS and other systems like DMS, LMS and TMS, document management system, LMS and learning management, RIMS is regulatory information. Then employee training and engagement, sustainability, efficiency. What I try to say is, when you make the digital system, it has a great impact, big impact on human life. When you are working for pharma, ensure that you are doing some novel couch. You never know when you go to a doctor when you are ill. Think, or some of your near and dear is ill. You think and go there. Then you will come to know what is the situation. You have heavy stomach pain. 90% will go when you go to the doctor and touches to you. It's there still, but the mental tension will get cured. When you take a medicine, we never know what medicine he has given. He wrote, he went to dispensary, he brought that, he opened the strip, kada, sip of water out. Isn't it? You never know what is there inside. But it gives a lot of relief. That's why these all are done by you, those who are doing the manufacturing and those who are doing the drugs ready from discovery till the post-market surveillance, and everywhere quality by design concept is very important and very much needed. Then applications, what I am trying to say, if you wanted to work in any of the applications so that you can be what you call computer literate, or you can be application literate and you can join any of the pharma companies. They are the value chain based applications which we have used, I have used specifically across discovery, formulation development, preclinical, clinical, regulatory submissions, analytical method and manufacturing process validation, scaling up commercial and multi-market specialization, testing and warehousing. Why I brought up here is, there are PLMs. See how the stack comes: CRM, customer relationship management, then PLM, mostly ERP, followed by PLM, MES, LIMS, DMS, in the sense LMS, followed by our L2, that is SCADA, DCS, and then the sensor from the machine. Machine is connected to a sensor. Sensor is our L0 level. Then it gives some intelligent programming in a PLC. Then it goes to the manufacturing execution system, which connects with other systems like LIMS, which controls the laboratory management information system, where the testing life cycle is done. Manufacturing execution system is the manufacturing life cycle is being happened, and learning management system, where learning life cycle is happening, where everybody is getting trained and every training records are being recorded. Like that, when you go to the ERP, the material management is also done over there. That coming from the CRM, customer relationship, customer needs, what customer required, everything boils down around the customer. So quality is very important, and quality is free. That is told by Devi, the quality guru. Quality is free means the cost of reproduction. If a batch is failed, if a rice bowl is spoiled, and cost of reproducing that is much less than first time doing right. If you follow first time quality full, then the cost of reproduction and cost of quality is free. That is being told by Deming. I forgot to write his name, but I was what is this? Quality is free. Now before here, what do you have to follow? Thank you. All were waiting. Thank you. Thank you so much. And be a quality output here. Be educated, not only qualified. Qualification helps being street smart, but education gives you somewhere little other smartness also. Thank you so much for this opportunity, and thank you all for your precious time during lunch time. Thank you.
Thank you so much, sir, for that comprehensive and insightful session. Your expertise illuminated the path towards smarter, safer pharmaceutical systems. Today's session has given us a powerful glimpse into the digital future where systems think, processes evolve, and industries grow smarter. We are grateful to both our distinguished speakers for sharing their time and experience, and to all of you for being a part of this transformative conversation. To honor Mr. Amit Kumar Rats and Mr. Manoj Kumar Nayak's invaluable contribution, I invite Dr. Supriya Patnaik, Vice Chancellor, Centurion University of Technology and Management, Bhubaneswar, to please come forward and felicitate them with a token of appreciation. Ma'am, please. To conclude this event, I now request Mr. Devashish Panda, CFO, to kindly deliver the vote of thanks.
Good afternoon, everybody. I would like to sincerely, express my gratitude for the, invited guest and the speakers who, enlighten us about so much that, we need to learn about what is happening in the industry and, how knowledge is across disciplines. So you have to understand that an IT engineer needs to understand pharmaceutical industry or how IOT has advanced to a next level of learning. So thank you so much, esteemed speakers, for spending some time with our friends. And thanks a lot to my team in Centurion, faculty members, to helping us arrange this assembly for students to learn and benefit from the experience sharing session. And also thanks a lot to Lokesh and placement team for bringing this opportunity to here. And most importantly, thanks a lot to my colleague, faculty colleagues, and most importantly, PC ma'am for giving us the time here. And most importantly, students, thank you for patiently listening and and I sincerely hope that you have learned something that you will take back and imbibe into your lives about education and qualification, the difference between them. I hope that it will stay with you for a long time and you become productive citizens of the country, irrespective of the industry where you join. Thank you, everyone.
Everyone may proceed